All right. So for this last example, we have some quiz scores, first quiz and second quiz. We're going to call this first quiz our X values and this second quiz our Y values. So we're going to plot the points. Okay, so here's my first quiz and my second quiz. All right, so I have 12, 10. So I'm going to find 12, which would be to the right of 10, and 10, and I'm going to plot a point. 42, 45. So 42 is between 40 and 45. Then I'm going to go up to 45, plot a point. 22 and 20. So 22 is right here. 20, maybe right in there. Okay. 35 and 36. 35, 36, right above 35. 8 and 13. So 8 is maybe here, 13 maybe there. And then 37 and 34. So 37, 34. All right, now in my mind, I'm going to think about what a line would possibly look like. Maybe something like that. Okay, so I'm going to say that's my best fitting trend line. I'm going to predict the value of the second quiz based off if I get a 20. So for my first quiz, if I get a 20, I'm going to say my second quiz score would be maybe a 21 or a 22. There can be more than one right prediction there. Okay. I find our correlation coefficient. So here's that big value for R. Okay, so I'm just going to start a table. My X values. My Y values. All right, then I'm going to do X times Y. So I'm multiplying these two values together. Then I have X squared, so I'm 12 times 12 is 144. 42 times 42, and so on. All right, and then Y squared, so 10 times 10 is 100, 45 times 45, and so on. All right, now I'm going to add these up. All right, so the sum of X is 156, that's an X. The sum of Y, the sum of XY, the sum of X squared, and the sum of Y squared. All right. Now, R is that big formula. All right, so we're just going to plug in what we have. N is 6 in this example, since we have 6 data points. So we have 6 times the sum of xy, which is 5,072, minus the sum of x times the sum of y. And sum of x squared, 50, minus the sum of x, 156, raised to the second power, n times the sum of y squared, minus the sum of y to the second power. All of that is under that square root symbol. All right, so I'm going to multiply this, and then I'm going to subtract them. And when I do, I got 5,784. I'm going to multiply those and subtract 156 squared. And when I did that, I got 5,964. Then I'm going to multiply that and subtract 158 to the second power. And when I did, I got 5,912. Oops. All right, now I'm going to multiply these two things together and take a square root. So I'm doing that step. And when I divided those, all right, rounded to 3 decimal places, we got R is 0.974. That's a pretty strong positive relationship. Okay. All right. So now I'm going to determine if that is significant at the 0.01 level. So let's go to our table here. We have N is 6 at the 0.01 level. So it looks like our critical value is 0.917. So the value we found was 0.974. That is bigger, so that it is statistically significant. All right. Pause it there.